from the January 2025 issue of Skilling's Mining Review. From sustainability to safety, efficiency to exploration, the mining sector is undergoing a transformation like never before. Once reliant on manual labor and traditional methods, today's operations are driven by cutting-edge technologies that aim to meet environmental, economic, and social demands. Join us as we explore how these advancements are revolutionizing mining practices and paving the way for a greener, smarter future. One of the most significant trends in mining is the shift towards electrification. Companies are replacing diesel-powered machinery with electric alternatives to reduce carbon emissions and operational costs. Take Fortescue Metals Group, for example. They've partnered with Liebherr in a $2.8 billion initiative to acquire a fleet of autonomous battery electric trucks, electric excavators, and battery-powered dozers. This move aligns with their goal of achieving net zero emissions from their Australian iron ore operations by 2030. Similarly, BHP Group is piloting Caterpillar's Cat Dynamic Energy Transfer System, designed to support both diesel-electric and battery-electric trucks, offering a dual benefit of reducing greenhouse gas emissions and lowering operating costs. Automation is becoming the cornerstone of modern mining. By adopting autonomous and remote-controlled machinery, companies are enhancing both safety and productivity. Anglo American's remote control technology for dozer operations at their Capcoal complex in Queensland allows operators to control heavy machinery from a safe distance, minimizing risks associated with manual operation. Meanwhile, Australian Droid and Robot has secured funding to develop mine monitoring robots capable of operating in hazardous conditions. These innovations reduce downtime, increase efficiency, and improve safety across the board. Artificial intelligence, AI, is taking mineral exploration to new heights. Startups like Cobalt Metals are harnessing AI to identify deposits of critical minerals, such as copper and lithium. By analyzing extensive datasets, AI can pinpoint high-potential mining zones more efficiently than traditional methods, saving time and resources while maximizing yield. The integration of advanced maintenance technologies is extending the lifespan of mining equipment. Mechatronics, in collaboration with TS, has developed carbon fiber reinforcement kits to enhance the durability and load capacity of mining machinery. This innovation not only reduces the environmental impact by replacing heavy steel components, but also supports decarbonization efforts across the industry. The Internet of Things, IoT, is transforming how mining companies operate. Real-time data collection from IoT-enabled sensors provides continuous updates on machinery performance, geological conditions, and operational efficiency. Rio Tinto's Mine of the Future program exemplifies this trend, with IoT sensors integrated across their Pilbara operations in Australia. These sensors enable remote monitoring, reducing downtime, and improving productivity by 15%. Similarly, Sandvik's AutoMiner system uses IoT to create a connected network of vehicles, ensuring optimal fleet coordination and enhanced safety. Hydrogen fuel cells are emerging as a clean alternative to diesel engines in heavy mining machinery, and Anglo American's NewGen zero-emission haulage solution, the world's largest hydrogen-powered mining truck, operates with a hybrid hydrogen fuel cell and lithium-ion battery system. This innovation represents a significant step towards achieving zero emissions while maintaining high performance. Other industry leaders, such as Komatsu, are also developing hydrogen-powered equipment, with plans for large-scale deployment by 2026. 3D printing is revolutionizing the way mining companies manage spare parts and equipment repairs. Caterpillar, for instance, uses 3D printing to produce critical components on demand, minimizing inventory needs and reducing lead times. This technology is especially advantageous for remote mining sites, where logistics challenges often delay maintenance operations. Research into 3D printed titanium parts by South32 and the University of Wollongong highlights the potential for lightweight, durable replacements for traditional steel components, reducing fuel consumption and emissions. Drones are increasingly being deployed in mining for exploration, surveying, and safety monitoring. Equipped with LiDAR technology, drones provide detailed geological data and map mineral-rich zones quickly and cost-effectively. Companies like Barrick Gold use drones to survey vast areas, enhancing precision and efficiency. Additionally, Drones are used to inspect hard-to-reach areas, such as underground tunnels and high-altitude sites, improving safety and speeding up operations. Collaborative robots, or cobots, are enabling humans and machines to work side by side in mining operations. Cobots handle repetitive or hazardous tasks, allowing human workers to focus on more strategic roles. For example, Vale is piloting cobots in its nickel processing plants to sort materials and handle chemicals, reducing exposure to harmful substances and improving overall efficiency. Despite these advancements, the mining industry faces challenges, including high initial costs, integration complexities, and the need for skilled personnel to manage these sophisticated systems. Regulatory frameworks must also adapt to keep pace with technological advancements. However, the potential benefits, from cost savings and efficiency gains to reduced environmental impact, make these investments worthwhile. Sustainability remains a key focus for the mining sector. Innovations like carbon capture and storage, CCS, water recycling systems, and renewable energy integration are driving the industry towards greener practices. Rio Tinto's pilot CCS technologies at its aluminum smelters and AngloGold Ashanti's water recycling systems in Ghana are prime examples of these efforts. Additionally, renewable energy projects like Goldfields Wind and Solar Microgrid at the Agnew Mine in Australia demonstrate how mining companies are reducing reliance on fossil fuels. The industry's transition to Mining 4.0 involves the integration of AI, machine learning, and digital twins to create smart, interconnected operations. Autonomous fleets, predictive maintenance, and real-time analytics are setting new benchmarks for efficiency and sustainability. Vale's use of digital twins at its iron ore mines in Brazil has reduced maintenance downtime by 20 and increased equipment lifespan, showcasing the immense potential of these technologies. From the podcast studios of Skilling Mining Review,